And we're live.
Excellent. It's my pleasure to introduce Prasad Yalamanchi, who's the founder and CEO of Lead Semantics. And he's bringing his extensive expertise in computational linguistics to, to commercial and applications and unstructured data. Okay,
Yeah, are we?
great. I'm not sure
We're
why
watching.
I'm getting that feedback. Do you know why, Joaquin?
Oh, you're getting a feedback? You may
Well,
have.
I could hear myself talking, but I think I closed the other tab. There we go.
Okay, perfect.
All right. Okay, Marianne introducing. Nope, I'm getting again.
You might have another window open that you might be on the stage.
Wait just a minute. Jeez. All right, maybe that'll do it. All right, Marianne introducing Prasad, take 3, without the echo.
Yeah.
Prasad's professional experience extends into major areas of interest within the field of computer science, ontology engineering, natural language processing, knowledge graph development, and AI. In addition to his work at Lead Semantics, Prasad also serves as chair in a number of ontology engineering and natural language processing training programs. Welcome, Prasad, and thank you for joining us.
Thank you so much, Marianne. That was a very gracious introduction, some of which are a little bit more than what they really are.
And
Um,
the tip of the iceberg of your experience in this area, and so it's my delight to be here with you, and to sort of ask some questions that I've always wanted to answer for myself. It's the indulgence of being the interviewer. Your practice of computational linguistics interests me. How do humans and AI process and produce language differently?
yeah. For just to clear the thing, I do not have any formal, training in computational linguistics. It is, something that I was interested in while I was doing my computer science graduate programs, in terms of knowledge engineering and linguistics. And I spent quite a bit of time for sure in that domain. So maybe you all can tell me if I'm qualified to answer these questions. But you asked a very, very exciting question right up front, right off the bat, if you will. So humans, we plan to communicate based on what it is that we want to get the other party, the receiving party, to um, understand from, so there is something in our minds in terms of our knowledge, or we'll come to that. So there is knowledge that drives the nature of communication that we intend to perform, and that kind of gets received by the other end of the communication. And so humans have that context in mind as they are framing these sentences, or they're framing their communication, whatever be the expressive, mechanism, be it, there are many modes of communication these days. I mean, not only these days, historically, actually, like drama and dance and whatnot, all the arts, for example. So what we intend to communicate is driven by what it is that we have in our minds that we want to communicate. And so that sets the framework of what gets transmitted. Versus the AI machines, they are literally driven by what patterns that completes, what are the patterns that they have recognized, and how to complete the next set of patterns that are maybe the next best pattern. So completing the next better pattern probably may match with what the previous description of what I just mentioned about how humans would probably
Right.
uh, communicate. It might seem like it is matching, but you cannot be sure that 100% of the time that's what will be the case, because the context is never part of the the machines as much
Ex-
as what humans carry. Yeah.
Exactly, and that's a great interest to me. And I know that within the computer science community, there's a great deal of discussion around the importance of embodiment and or consciousness. That whether or not those are part of intelligence, but they're certainly part of how we communicate with each other. That subtle part. In addition to which, as you mentioned, the idea of um, the manners in which we communicate include cultural, uh, there's vocal, the intonation of certain tones in our voice when we're talking with chatbots.
Mhm.
How how do we uh, how best can we bring those into these applications?
Right. So as you mentioned, clearly that embodied, like all the different senses are working in as humans, try to formulate what needs to be, framed in the communication. Um, all of that probably is not taking place when an AI language model is communicating. Although we hear about all these, not just here, we have experienced these multimodal language models and all that, but they don't have these cultural aspects to the same level. There are just too many facets
Hmm.
of our human experience that in any given instance of a communication, um, we are picking and choosing what aspect of the knowledge frame that we are dealing with at that moment that fits the context in so many different ways, and so that's what completes the communication. And we always have an eye on what the receiving end, is it something that people would be able to make sense of, they are able to interpret, and all of those things come into play before we even formulate our sentences.
Exactly right. And so, one of the tools that I would like to do a deeper dive on is an area that you're well versed in, and that is ontology. And so, where do ontologies and knowledge graphs then, where do they play a role in the design, the development, and the deployment of these applications, in addition to the ongoing development of them? Because once they're out in the wild, then we do the
Yeah.
continued training, hopefully.
Right, right. I'll just take one step back. It's a loaded question that you asked.
I,
I
I'm
mean, all
sorry.
these questions are wonderful. I mean, serious questions. I mean, I wish I knew we were going to talk more beyond, the classic computer science centric approach to ontologies and information architecture. It looks like this is an exciting
We'll
discussion.
get to that.
Yeah. Knowledge is at the heart of our communication. We don't have anything to communicate if you don't have knowledge to communicate. Communication in the first place, whatever the mechanism has been developed to communicate knowledge, definitions aside, broadly that is what it is. So all the expressive systems were intended to communicate knowledge. And
Maybe,
so, and yeah.
I was just going to say maybe that's the problem is that we want to communicate, but the machines just want to process.
Exactly, and and it so happens, some of that processing, and not only some of it, to the extent that all the blue scores and this score and all those scores, they point to how well they are able to measure up to what it is that we normally do as human communications, right? And so they seem to be improving, but granted, with the current architectures, we can get to that. It'll never be the same thing as an ontology-driven human communication. Even as humans are exchanging, or communicating, there is an ontology at play. It's like ontology is sets of concepts and their interrelationships that are bound by the rules of what is expected and whatnot, whatever that we intended it to be at the time, to be able to communicate the knowledge at play. So the goal is to communicate that knowledge, and
Right.
then you frame this language to carry that knowledge, the constituents of this knowledge, the meaning of the knowledge is all carried over in the actual manifest language. It is received by the receiver, and then they interpret, hopefully with the same ontology, and so that's when they have interpreted to mean exactly what you intended as a source.
Exactly right. And And in a sense, as I mentioned in my presentation, John Seeley Brown has done a lot of research on this, the idea of sense making, and how there is that internal process where we take in what the information that we get and internalize that and make it specific to ourselves. And so ontology then is a methodology of sort of structuring that externally. How can we develop our own ontologies and make sure that we have a shared understanding then?
Absolutely. For communication to be successful, there
Mhm.
must be a shared ontology. So, in other words, the ontology itself is concepts and their interrelationships and so on. And these concepts are, whatever the subject that we are dealing with, the domain that we are dealing with, the context that is at play, whatever the contexts that are significant that need to be communicated about and their interrelationships, they carry the meaning in a structured fashion. And that is available to, computational purposes using semantic technology, for
Right,
example.
right.
Yeah.
So, getting back to the ontology part of it, what are three or more items or that front end information architects, like many of us here, get wrong about ontologies? What don't we know that we should know in terms of finding them, developing them, refining them?
I mean, any domain ontology is like an organizing, is like the structure of knowledge. Let's say,
Hmm.
the constituents of knowledge, and how you want to organize and structure them, so that with the purpose of all these goals of primarily to be able to communicate, which is like your integration with anybody else that may have been producing systems using a similar ontology, so you are able to communicate and integrate, and you are disambiguating the subject area in the first place. Now coming to information architecture, for example, the
Right.
user interface, what are the constituents of this field? Are we talking about user interface artifacts? Are we talking about behavioral artifacts? I mean, clearly, at the end goal of a good information architecture must be a good user experience. So, what are the constituents of user experience? That would say, as we talked about off stage, that most of the user interface are slowly evolving towards a single search bar kind of a thing for humans,
Yes.
as opposed to having all kinds of user interface elements. How is that delivering better user experience than the alternative? So what constitutes that?
Yeah, so often though, it results in misaligned objectives. And my primary example of a misaligned objective is we all know about the Donner Party, or I hope many of us do, and they were what, late 19th century, a
Mhm.
group that were trying to migrate west. And their goal was to get to California by November, uh, when in actuality, their goal should have been to get to California alive. Because in pursuing the get to by their November, they ended up getting caught in the Sierra Nevada mountains
Mhm.
in a blizzard. And I find that oftentimes in my work with, on projects where there's like a date driven as opposed to a user driven. Now, with ontologies, and as you mentioned with search, what I find is so often there are so many choices offered, especially with regard to faceted search, that the customers facet themselves out of any answers whatsoever. There are too many choices that are
Right.
made that influence that. And I'm just
Right.
wondering how we can, mitigate that.
Right. I wouldn't know exactly specifically for that faceted, what type of facets may be contextually relevant. It could be, the person's interests, and maybe the subject and domain area has so many facets that, you will just, fleecing it down to some a handful of facets may not be doing justice to what all is present in the subject area itself. But
Mhm.
granted, the ontology, the itself allows for you to organize the elements of the knowledge that at hand, right? I mean, that's as a very general, broad definition of it. And so, in that organization, that allows you to, rebalance the structures, reorganize structures. That is one of the trait of a good design, that it is flexible, and all the other things, keeping the rest of the teams in mind. It is, you are able to integrate with other systems, you are able to reuse what you have done, for example, and then it is disambiguated. All those other characteristics kind of tell you whether the ontology is well designed. And of course, clearly the competency question, so to speak, what is that purpose of this new ontology that we are creating? That ought to be the driver, as you rightly said. Your example, of the goal ought to be that you stay alive through all this, arduous journey.
The appropriate
So
aligned objectives, yes.
absolutely. So that ought to drive every decision that you are doing. And ontology development is a highly iterative process, because one differentiating aspect of ontology development is that, unlike the other modeling techniques like object oriented and
Mhm.
relational and so on, uh, is that this is rooted in trying to mimic what is there in reality. So it is very easy for you to test and try the constructs that you have come up with. Are they going to be able to withstand the test of time? And some
Ex
other team, when they are looking at the same problem, it's a lot easy to have them be guided to arrive at the same construct, because it is rooted in reality. It's independent of these two teams.
Exactly. And oftentimes, what I find is that, um, the goals are dictated by, influences such as stakeholder or marketing elements that are not necessarily aligned with what the customers want.
Yeah,
Uh, and so, I find that big in SEO is the idea of intent, finding the user's intent and structuring so that they can realize that intent. But oftentimes, and what I'm happy to hear you talk about is the refinement, because intent is not static. It develops as they learn more. So how can we create knowledge structures or ontologies that allow for that? That,
yeah.
create not just the hierarchical, but the horizontal relationships between concepts and content that enable customers to find what they wanted, but also find what they didn't know they wanted.
Absolutely. And hierarchy is just one type of relationship, and with the ontology, what you're bringing to table is that, as you rightly said, there are relationships all around. I mean, it is like what is there in real world. So as you create classes and subclasses, which is how you say, super concepts versus sub concepts and so on, and they all have different properties, and they're related to other concepts, and so all of that has a place in this ontology. And ontologies are rooted in, as I said, in the real world. And and the most exciting thing about ontology development right now is that semantic technology, which is the popular technology within this ontology area, is a highly standards based
Mhm.
and rigorously tested for what it is available, like all the essential things for modeling, essential things for actual encoding and decoding, serialization of the data that goes into these models, and the data, all the instance data, if you will. So you create the models and you kind of tag these instances that they belong to these the model elements. And then the query language. So all aspects of handling information using this ontology and semantic technology are all standards based. And so when you are modifying, and because ontologies are meant to allow for modifications, because that's how our learning happens, and all the knowledge is dynamic, to the extent that we are exposed to the context and so on. and the standards allow for it. And so as the data is getting accumulated and things like that, it really moves with the changing understanding of the terrain.
And so critically important, as I have come to understand, as a result of losing the charger for my laptop. And so found that the Dell laptop charger works on my Lenovo because of the USB-C connectors. Thank goodness and thank you all, and how long it took for us to get there. Um, do you, can you tell us some of the dominant standards for these projects, the shared standards for ontology development?
Yeah. So typically, the ontology development has kind of, at least to my best knowledge, has come out of the Defense Department of Defense, and a lot of these research projects, the U.S. government projects from probably 3-4 decades ago. Um, the majority of the systems that are being developed in the commercial world are using the standards of OWL for modeling
Mhm.
ontologies. OWL stands for Ontology Web
Right,
Language, uh, and then it's all rooted in the serialization and encoding decoding standards are RDF centric. This is literally taking from Tim Berners-Lee's talk about semantic web
right,
standard. RDF stands for Resource Description Framework, and so
right.
that allows for every element, at an atomic level, whatever that we want to model in our ontologies, and then collect data against this model. And then to house all the data that we encode in these RDF, there are standards for how you put it into a database for these kind of triple stores. RDF, these are called RDF triples, and the
Mhm.
data that you formulate that meet these OWL standards. And this data can go into a triple store, so-called RDF triple stores. And then you want to query, much like any other database that we may be familiar with, like SQL, you have SQL database and an SQL protocol to search. In this case, the protocol is Sparkle.
Mhm.
It's a query language that is standardized for RDF triple stores.
Right.
And so you have all elements that are there. And these are, so one organization doing a project, using semantic technology, creating their knowledge graphs and, whatnot, they can easily get out of any vendor they may be using, as long as they are tied to these standards, to another vendor, or maybe use the data out of their databases or knowledge graphs, and integrate with data from another knowledge graph from another company or another department, maybe using a different vendor, as long as they all subscribe to these standards.
Mhm. Excellent, excellent, and also a great list of skills and tools that we should use to, become more proficient with ontologies. Much has been made about the, algorithmic bias in most large language models that are out in the wild now. How can ontology be applied as an effective solution for this?
So, when we define an ontology, what we are saying is, in this particular domain of, or this application area, we expect the data to conform to this ontology.
Mhm.
Anything that does not conform to this ontology is, is flagged as not meeting the requirement. And so, no matter the process, be it, very highly trained latest models or the earliest models, or low parameter models, whatever, whenever they produce anything that conforms to an ontology, so you make it a point to have this ontology as a guideline, of receiving this data coming out of the processed, the workflows off of these LLMs, so to speak.
Right.
You are good to go on the other side, because that is the ontology that you have said as meeting your guideline. And so one of the biggest benefits of using ontologies is you can, on one side, we can keep on training these models with additional training data and all of that. And additional training data will only try to detect more patterns. But as long as the ontology is what you are gauging your quality metrics by, it doesn't matter. beyond a threshold. And in that sense, once you have a good ontology for an application, as good as even GPT-4 or Gemini, whichever the versions they are, they will meet most of your requirements already.
Exactly, and I'm just wondering if they have ontologists on board. I know that Google did a study, um, where the focus of the study was how human factors professionals could learn more about computer science, the computer science of AI, to be effective contributors. Um, the one of the issues with the study is that out of the 32 participants, over half of them worked at Google. So they may be at an advantage. But in the end, Google developed what they call PAIR, which is their guidelines and tutorials to help the human factors people learn more about AI. I'm just wondering, how can we mount some sort of an education program so that we can educate the computer scientists and the developers about ontologies and knowledge graphs and information architecture?
It's that's such an important question. So in high school, at a high school level, for example, there is a curriculum. There is K-12, and then there is this other European style IB program.
Right.
Uh, why I go back to that is within the IB program, there is a class or a subject that's called theory of knowledge.
Hmm.
Right at the age when these minds are kind of just flourishing or beginning to understand the rest of the world. Uh, and theory of knowledge is, I was privileged to kind of, talk to some students and, on this very subject at one time.
Right.
And it is so important that, knowledge is different than language. And most, practitioners even today, I run into with machine learning backgrounds and such, it's very, those two are granted very intertwined concepts. It's very difficult to separate one from the other, and because wherever language exists, it exists because of communicating knowledge. And whenever you say knowledge exists, you wouldn't know otherwise, other than to be communicated about it. There is so the communication and the subject of communication, which is the knowledge, are intertwined. These are like two sides of the same coin. That's a tagline for our company actually. uh, you know and so learning about knowledge, and the more, whether it need not be scientific in the way that ontologies and all of that, but little more rigorous than what is there in document management systems and all of that. We need to kind of elevate that aspect of it, just alert folks that knowledge is different than the language, and it's just not like document management systems and content management systems and all that. It is much more than that. And then the structures of the constituents of this knowledge. I mean, just be aware that there are constituents to this knowledge. And then, once you have more than one, it needs to be organized. There is a better way and not so better way of organizing it. And what would be required of that would be an ontology.
I think so, and absolutely. We just need to get them to adopt this. I don't know how we'll do that. Maybe we all buy stock in Google and force it, or the Department of Justice will do it for us. Um, what are oh, I already asked that. I wanted to talk more about the magic of the ontology tools
Yeah.
and how one models an ontology. I'm just used to seeing the sort of, hierarchical, this is a child of this, is a part of that, is a part of this.
Right. Yeah. So the taxonomy side of it will probably kind of highlight the hierarchies. The
Mhm.
ontology side of it kind of will really stretch it out in terms of the relationships. Even in the basic taxonomy, you may say something A is related to B, but in what ways is it related? There is a whole bunch of ways that two things can be related. Two elements of reality can be related, and so now we are promoting in language what that relationship might be,
Right.
and to have a construct that is more engineered, ontology would support that. you know
So in the end, I guess I'm confused as to how one would start building an ontology. Say for, let's use, let's use the Department of Justice as an example, or something that you're familiar with, anyone, their enterprise, their products, or their organization.
So one critical
How
thing
do you?
is that identify what are the discrete concepts. I'm
Mhm.
sure there are documents that are describing their business and all the things that they deal with in their business as they create their products. All the processes and things like that. These documents will necessarily contain the terms in which by which they are describing the constituents of their products or what will get transformed into their final products.
So that would be
All, yeah.
features and audience or intended audience or things like
Yeah, you
that?
can literally start with all the nouns, for example. All
Mhm.
nouns, noun phrases would end up becoming candidates and fodder for your concepts, ultimately. They may not be one for one, or it may be a fraction of those things, but somewhere in there are rooted the critical concepts around which the business is,
Mhm.
focused on. Similarly, all the interrelationships would probably be rooted around verbs, but not necessarily so. Some of those nouns and their properties may end up becoming the relationships as well. Uh, and so it is in that description because language is what is describing the knowledge of the business, and knowledge of the business has all the constituents that make up the products and the processes and how and all of that.
Hey,
Uh,
Joaquin.
just a quick point. All opinions expressed on this platform are owned by the speakers themselves.
Yes.
Nobody's representing anybody.
Oh, no.
Um, I did have one question for you, Prasad.
Yeah.
Yeah.
Usually, people have established metadata or they have established taxonomies. That is the gateway drug for ontology development. How do you engage people that already have some existing infrastructure for them to then expand that over to the ontology?
Right. So if you have a metadata and taxonomy, for example, right? And so all the constructs of taxonomy will be candidates for them. So in other words, all the terminology of your subject area is one way or another in the taxonomy. One, in some ways, some of them, when it comes to relationships, may or may not be there. But you start questioning about, are these, concepts, are they interrelated and what type of relationships exist? Besides saying this is broader and narrower, than the other, I mean, are they related? And when they are related, in what ways are they related? Are they like, for example, something is a name. So it is not necessarily the hierarchy is not capturing that relationship, right? Hierarchy is talking about, same properties, kind of, appearing in the next concept. Whereas relationship is saying one way or another, these two are going to work together or communicate with each other in some process, in the way that they are assembled, in the way that they present themselves to the user. There is some context in which these two are together.
Oh, we can't hear you.
We can't hear you.
Sorry about that.
There you go.
Are there any last pieces of insight in adopting ontologies, even just at an elementary level to get started? I know we're closing in on the a few minutes left.
Yeah.
So
Yeah.
just to wrap up
So
your thoughts.
the context right now cannot be better for ontology and knowledge graphs, given that generative AI has literally been a rage over last 2 years. Uh, to the point where all the experts in this knowledge and language and all of AI have been um, literally focused on generative AI, thinking that it might solve everything and anything related to AI and knowledge. And one way or another, as I was mentioning, language and knowledge are kind of intertwined in people's minds, and so there is an expectation that generative AI would solve it. And some of the biggest powers still kind of parrot the same kind of sentiment, which cannot be true. That language alone cannot carry the knowledge. Of course, language carries the knowledge, but it is not able to carry. See, knowledge has a context in which it is really, valid. Unless the context goes with the language, the knowledge cannot be really spoken for in many ways. And so the area of knowledge graphs and ontologies are the missing piece in this overall AI. The tooling is all available in terms of standards and tools, as well as best practice. And some of the people in symbolic AI and they have been doing this for their entire careers. And so this is pretty mature technology and pretty mature best practice, pretty mature understanding of how far these things can go. Now the time is ripe to, now that generative AI has shed light in this area, and that gap can only be filled by knowledge and knowledge tooling.
It's very interesting to me that most people I encounter don't know the history of AI, and that all of this technology was developed early on in the 60s. What's his name? Weissenbaum developed a chatbot called Eliza that was brought out in the 60s and was so proficient that his secretary asked him to leave the room so she could ask it questions, not realizing that it was programmed to respond. Now we live in a world. What happened is the AI winter came in the 80s and the government stopped funding it. And now what we have is an endless source of funding and hardware resources to support. But what we don't have is the oversight and input on the impacts that this technology is having on our society, on our acquisition of knowledge, and what we consider to be intelligence.
Right, right. Just to add to one thing, Joaquin, that you asked, how do folks that are not in this field, and they may be in generative AI, but they are interested in doing knowledge graphs and ontologies. We have conducted some free workshops on this very platform some time back. After the talk was over, there was plenty of requests, wanting to get onto that. I'm pretty sure there are other groups and other teams that do that. The material is there. It is highly standardized stuff, ontology development. There is plenty of material on the web. But of course, you would need some guiding group or some experienced person that kind of lead you in the way. The big words, Marianne would know, ontologies, these are not polite words in decent conversations. These are pretty dense words, but they need not be that way. Once you scratch the surface, people will see some familiar ground and then start to relate to how it really starts making sense to their problems.
Well, thank you very much, Prasad, for that clarification point. With all that being said, we're going to take a brief intermission, and then we're going to move on to the next live interview. Prasad, Marianne, thank you very much.
My gratitude to Prasad. It was an illuminating conversation.
Thank you so much, Marianne. You led the way here. Yeah, thanks.
See you guys soon.